everybody, welcome to the second part of our polar unit. This should be the second video you're watching, video 6. And we are going to be graphing some complex numbers. So go ahead and make sure you have your worksheet ready and let's go. Alright, so we're going to be graphing these complex numbers which has one real part and one imaginary part. And to do this we have to introduce the complex plane. Typically in our real plane we have an x comma y and we graph using ordered pairs. When we were in polar we had an r and a theta giving us a radius and a angle measure that told us which direction we were headed. So the complex plane, a new plane for you, has the horizontal axis being real and the vertical axis is our imaginary axis. So you're going to be graphing these in kind of a two-part thing, but it's going to seem very comfortable because it's very much like graphing x comma y. So if I were to just put a scale on here, so I'm going to put 5 in each direction. Then I were to plot 2 minus 3i. I'm going to go 2 in the real direction, and I'm going to go down 3 because I'm going negative in the imaginary direction. And this would be the point 2 minus 3i. For the next one, negative 3 plus 4i. So I'm going negative 3 in the real direction, but I'm going positive 4 in the imaginary direction. So this is my point negative 3 plus 4i. And lastly, another example, we have negative 4 in the real direction and negative 1 in the imaginary direction. So just as you probably pictured, a negative negative would be in the third quadrant. Alright, let's go ahead and try something else. So here we're going to be graphing the resultant of the sum, meaning we're going to be adding them together, of two complex numbers. And we're going to look at it two-way. I can just add two complex numbers and then plot the answer. So here I would do this. I would do 4 plus 1 is 5. And then I'd have I plus 3i to be 4i. So I could just go ahead and plot 5 plus 4i. 1, 2, 3, 4, 5. 1, 2, 3, 4. So 5 plus 4i would give me an answer here. But let's take a look at what would happen if I were to just graph the first one, add the second one on, and would I land in the same place? You're probably thinking, if she's asking, that means yes. But let's try it together. So if I start by graphing 4 plus 1i, that's here. And then if I were to add 1 real and 3 imaginary, so I add 1 real and I add 3 imaginaries, and I actually do end up at exactly where I wanted to. So it's just another way to think about it. I could just start with the first one and then add the parts of the second one. So we're going to try these first two together, and then I'm going to leave another one for you to try on your own. So I'm going to be adding 5 real and 2 imaginary. So here's point 1 that I'm going to start from. And then I'm going to do 3 more reals and 5 going down in the negative direction, 5 imaginary. Well, I'm already at 2 imaginary. So here's my 3 more reals. And then I'm going to go down 1, 2, 1, 2, 3 for a total of 5. This is my resultant vector. I said vector, my resultant complex number. And I have 8 minus 3i. And if that's where I am, 8 minus 3i, then I've done it correctly. Let's try another one. This time I'm going to go negative 3 and down 2i. So I'm starting in the fourth quadrant. And it says go 1 more negative in the real direction, but go 6 in the imaginary direction, positive. So I'm down 2. 1, 2, 3, 4 more makes 6. So this should be my answer. Now, according to my graph, I am at negative 4, positive 4i. Oops, I should not have put a comma in there. No need for the comma. So plus 4i. And in fact, that's exactly where I am. I'm at negative 4 plus 4i. So, no commas. Alright, so this last one is for you to try on your own. You've got room on your notebook paper and your note sheet there to try 4 minus I plus 2 minus 3i. So that's it, guys. We're just going to take just a reminder that when you're graphing complex numbers, you are looking at the x-axis being the real axis, and then here'd be your negative real, and this being your imaginary, and going down would be your negative imaginary. And these are not vectors, they're just a point, so it'll just be a spot, and then you'll be naming it as A plus BI, and that would be your final result. Great job.